Oh, yeah. Rectangular sheet. A rectangular sheet is 45 centimeter length and 24 centimeter in breadth, from which I'm going to take a square piece and make it into a laddu box. These are called laddu box sums. So when you fold, you get this to be 45, my length to be 45 minus 2x, breadth to be 45 minus 2x, the height to be x. The length, volume has to be maximum. Volume is length into breadth into height, which is 45 minus 2x into 24 minus 2x into x. I have an issue when this x is separate, so I'll bring it in so that it's only u and v. So 45 minus 2x into 24x minus 2x square. So that it's become one variable, I can differentiate one with everything with respect, it's u and v. 45 minus 2x, முதல்ல இருக்கிறது அப்படியே, ரெண்டாவது டிஃப்ரென்ஷியேட் பண்ணால் minus 4x ப்ளஸ் ரெண்டாவது இருக்கிறத அப்படியே எழுது, முதலுக்கு டிஃப்ரென்ஷியேட் பண்ணால் -2. யா முதல்ல இருக்கிறது அப்படியே எழுது, ரெண்டாவதுக்கு டிஃப்ரென்ஷியேட் பண்ணால் 24 minus 4x ப்ளஸ் ரெண்டாவது இருக்கிறது அப்படியே எழுது, முதலுக்கு டிஃப்ரென்ஷியேட் பண்ணால் -2 is equal to 0. Therefore this is equal to this. So 45 minus 2x have differentiated, right? This is the differentiated value, right? So 45 minus 2x into 24 minus 4x is equal to 2 times 24 minus 2x square. From this I can take a 2 out. It will become a 12 minus 2x and this 2 will get cancelled. Correct? From this again I can take a 2 out. It will become 6 minus x and this will become 12 minus x square. And I have a 45 minus 2x. I'm going to multiply it inside. 6 5s are 30, 6 4s are 24, 270 minus 45x minus 12x plus 2x square is equal to 12 minus x square. Bring everything to the left side. It will become 3x square and a 45 and this will become minus 57x. And the 12 comes this side, it's 270 minus 12, 8, 258 is it? Plus 258 is equal to 0. Can I cancel this whole thing with 3 tables? Is the divisibility working? Yeah. So x square minus 3 1s are 3, 9 3s 27 plus 8 3s are 24, 6 3s are 18 is equal to 0. Now can I factorize 86? It is 2 and 4 and a 3. What? Something is wrong. 8 3s 24, 6 3s are 18. My calculation. 270 minus 45x minus 12x plus 2x square is equal to 12 minus x square. 270 minus 12 is 258 minus 57x. So maybe here itself I made a mistake. Length into breadth into height. 45 minus 2x into 24 minus 24x minus 2x square. முதல்ல இருக்கிறது அப்படியே இது, ரெண்டாவது இருக்கிறது டிஃப்ரென்ஷியேட் பண்ணால் 24 minus 4x ப்ளஸ் ரெண்டாவது இருக்கிறது அப்படியே இது, முதலுக்கு டிஃப்ரென்ஷியேட் பண்ணால் -2. So then that 45 minus 2x, 24 minus 4x is equal to 24 minus 2x square into 2. You take a 2 out from this, become 12 minus 2x and a 2 and 2 gets cancelled. Again take a 2 out from this, it's 6 minus x and this will become 12 minus x square. Everything is perfect. 6 5s are 30, 6 4s 24, 270 minus 45x minus 12x plus 2x square is equal to 12 minus x square. A 3x square minus 57x plus 258. 3 1s are 3, 9 3s 27, 8 3s 24, 6 3s 18. Everything is fine. 4 2s are 8, 3 2s are 6. Again I'm stuck. What is this? What can be the issue? Let me try the sum once again. I really don't know what is the issue. So length into breadth into height. It is what are the 45 and 24, which is correct only. 45 minus 2x into 24 minus 2x into x, which is 45 minus 2x into 24x minus 2x square, and dv with respect to dx is a 45 minus 2x into 24 minus 4x plus a 24x minus 2x square into minus 2. So I'm going to solve this. I'm going to take a 2 out from here, which makes it, I can take a 4 itself. Okay, now I'll take a 2 out. A 12 minus 2x, so that the 2 got cancelled. Now I can take another 2 out, which will make it 6 minus x, and a 2 out from here will make a, after putting equal to, it will become 12x minus x square, and here already have a 45 minus 2x here. So bringing it to the other side, what is this I'm doing? It's 6 5s are 30, 6 4s are 24, 270. Is that what I got before also?
Yes, ma'am.
What is this? Minus 45x minus 12x plus 2x square is equal to 12x minus x square. So 3x square. Here I wrote something else there, right? 45x minus 67x minus 12x will be 79x. 57 minus 12x, right? 69, huh? Then what is it? That's 12x. I wrote it as 12.
Yes, ma'am.
I wrote it as 12. That was my mistake. Yeah? So then let's continue. Plus 270. Now it's sorted. X square minus 3 2s are 3 3s are 9 plus 9 3s are 90 is 18 5s are. X square minus 18x minus 5x plus 90 is equal to 0. X into x minus 18 minus 5 into x minus 18 is equal to 0. Therefore x is equal to 5 or x is equal to 18. You can't possibly cut an 18 out of a 24 here and here. It's not possible. This is not applicable. So x is equal to 5 is the part you're going to cut. What is the question? The cut part is a question, or what should be the side you should cut off so that the volume, that's all. X is equal to 5. But whether it's maxima or minima, you should take the differentiated value and differentiate it once again. So are we clear here? I made a mistake. So then you're doing it as you and me. முதல்ல இருக்கிறது அப்படியே இது, ரெண்டாவது இருக்கிற டிஃபரன்ஷியேட் பண்ணா 24 minus 4x plus ரெண்டாவது இருக்கிறது அப்படியே இது, முதல்ல இருக்கிற differentiate பண்ணா you get this. This is the differentiated value. You have to double differentiate and verify whether it's positive or negative. Let's do the double differentiation verification. I hate it when I scroll. I have to scroll down. D square v by dx square. So let's write this once again. I am very confused. It's actually 45 minus 2x into 24 minus 4x plus 24x minus 2x square into minus 2, which means it's a minus 2 here, and I have to double differentiate this. So when I see this, when I have double differentiate, this itself is u and v, correct? So then it's 45 minus 2x into differentiate on this is minus 4 plus a 24 minus 4x into differentiation of first term is minus 2. Minus 2 into differentiation of this is 24 minus 4x. And you know x is equal to 5. In all this d square by b by dx square, you put v as x as 5. So 45 minus 5 2s are 10 minus 4 plus 24 minus 5 4s are 20 minus 2. Minus 2 into 24 minus 20. Just verify it's negative or positive. So this is a 35 minus 4 plus a 4 into minus 2. Minus 2 into 4. It's minus 8. Minus 8. Definitely it's negative. Therefore the value that you got is for maximum. That's all. Are you clear? Sorry, I made a mistake there when I took it to the other side. I wrote it as 12 and not 12x, and that's my mistake. I'm sorry guys, I hope you understood. So let's go to 19th question. Show that of all the rectangles inscribed in a circle, In a circle, what is constant is the radius. So what is given is the radius of the circle.
Yes.
Let's keep it as r. You're going to inscribe a rectangle. You can inscribe a rectangle like this, or a rectangle like this, or a rectangle like this. Many things you can inscribe. They are saying the one which has got maximum area has to be a square. When you read the question, you know how you should read. Show that of all the rectangles inscribed in a fixed circle, the one which has got a maximum area is a square. So what is given you should write on the right side. What has to be maxima, minima, you have to write on the left side. What has to be maxima, minima? The area of the rectangle. Area of the rectangle which is L into B that you are going to inscribe inside a circle. You know that this is R. This is also R. Therefore the diagonal is 2R and therefore hypotenuse is 2R. This is length and this is breadth. So using this triangle you can write 2R the whole square is equal to L square plus B square, which is what is written from the given. Because R is what is given. You can't have two variables when you differentiate. You can write L in terms, B in terms of L. So B square is equal to 4R square minus L square. So A is equal to L into B, where B can be written as root of 4R square minus L square, where R is a constant. It's given. Only L is a variable. Therefore now you can differentiate it as dA by dL. In maxima, minima, you are allowed to square both sides. Why? Because a function is maxima, you differentiate it equal to 0, you get an x value. When you function the square and differentiate it equal to 0, you get the same x value. Or maxima, minima, you are allowed to square the function and you see the square root. So then you can write a square. But don't bother write it as z. The a square can be written as z is equal to L square into 4R square minus L square. Take it in and differentiate. 4R square L square minus L to the power 4. Let's now differentiate it as dz by dl. What are the constant? 4 is a constant, R square is a constant, L square can be differentiated with respect to L. So 4R square into 2L minus 4L cube is equal to 0. Therefore this is equal to this. So 4R square into 2L is equal to 4L cube. L and L square, L cube get cancelled. 4 and 4 get cancelled. 2R square is equal to L square. Root 2 capital R is equal to L. What is given is capital R. You found the length in terms of given radius. Now take it, go swing in. Find what is breadth. B square is equal to 4R square minus L square. You know L is nothing but this. So B square is equal to 4R square minus 2R square, which is also 2R square. So B is equal to root 2R. Therefore length is also root 2R, breadth is also root 2R. When it is maximum, it becomes a square. The rectangle which is inscribed inside a circle attains a maximum area when the rectangle becomes a square. But we don't know whether it's maximum area or minimum area. So differentiated value has to be double differentiated. Which is the differentiated value? You do the verification here itself. 4R square is a constant, a 2L becomes 2. Minus 4 3 is a 12 L square. You know that L is equal to root 2R, substitute here. 4R square, it's 8R square, minus 12 into L itself, L square, is 2R square. It's 24R square, therefore negative, therefore what we got is maxima. Understood? Are they asking for the area of the rectangle? No. They are asking you to show only when it will be maximum. When it is a square, it is maximum. Are you clear? Can I go to next sum? Next sum is the 20th question. The 20th question. Show that the right circular cylinder of given surface area and maximum volume such that its height is equal to the diameter. Oh, never read the full question. What is given? Right side. What is given? Given surface of a right circular cylinder. What is the surface area of a cylinder? Cylinder is like this. A 2 pi r h plus 2 pi r square. Curve surface is 2 pi r h. Inga or pi r square, inga or pi r square. So 2 pi r h plus 2 pi r square is the total surface area, and what is given is the total surface area. S is given. Given a right lady. Now read the question. What has to be maximum, minimum? The volume of the cylinder has to be maximum. You should read the question like that. So the volume has to be maximum. What is maximum, minimum? Is the volume. What is the volume of the cylinder? Pi r square h. You can't have two variables. So using given, you're going to write one in terms of the other. You can't possibly segregate r because it's an r and a r square. You can't take common. Therefore, you can write what is h. H is equal to s minus 2 pi r square by 2 pi r. And substitute that h here. So, volume is equal to pi r square into s minus 2 pi r square by 2 pi r. The pi and pi get cancelled, r and r get cancelled. The volume itself is SR minus 2 pi r cube. Correct? So, we haven't even differentiated. We just found what is V. One in terms of the other. We've solved it and kept it. Now, we can do dV by dr by 2. And what is constant? 2 is a constant, S is a constant, pi is a constant, 2 pi, only small r is a variable. So, dV by dr, 1 by 2 can be taken out common. S is a constant, dr by dr is 1. Minus 2 pi into 3, r cube is 3r square into dr by dr is again 1. I can equate this to 0. So, I get S is equal to 6 pi r square. First, S is equal to 2 pi r h plus 2 pi r square. Instead S, right, 6 pi r square is equal to 2 pi r h plus 2 pi r square. Take it that side. 4 pi r square is equal to 2 pi r h. Pi and pi get cancelled. 2 and 4 get cancelled. R and r get cancelled. 2r is equal to h. Again go like this. You know 2r is equal to h. That's all its question. Such that the height is equal to height is equal to diameter. When you equate itself, you don't have to even read what do you want. You have to write given on the right side. What has to be maximum minimum on the left. Whatever answer you get is what is the question to prove that. So 2r is equal to h. Now I don't know whether it's maxima or minima. So take the differentiated value, which is this, and differentiate it once again. S is a constant. So 0. So it's minus 3 to 6 is 2, so 12 pi r. It's negative. Correct? And therefore it is maxima. Are you clear? Let's go to next question. 21st question, is it?
Yes, ma'am.
Of all the closed cylindrical can, see, draw a closed cylindrical can. Of given volume, what is given is the volume. It's given to be how much?
Cubic centimeter.
100 centimeter cube. Therefore, you write 100 is equal to, what is the volume cylinder? Pi r square h. And this is what is given. What has to be maximum in the question?
Minimum surface area should be found.
Minimum surface area. So, minimum or maximum in this question, 21st question, is the surface area. Surface area is yes, which is 2 pi r h plus 2 pi r square. Is it open cylinder or closed cylinder, whatever?
Closed cylinder.
So 2 pi r h plus 2 pi r square. For this to be maximum differentiated, but you have too many variables. You can write from here, there's an r and a h, so you can write h to be 100 by pi r square and substitute here. S is equal to 2 pi r 100 by pi r square plus a 2 pi r square. Beautiful, converted itself quickly into one variable. S is equal to 200, pi and pi also gets cancelled. 200 by r plus a 2 pi r square. Now I can differentiate it as ds by dr. 200 is a constant, minus 1 by r square, 1 by r differentiation. You know that? Plus 4 pi r is equal to 0. 200 by r square is equal to 4 pi r square. 200 itself is 4 pi r to the
4 pi r.
differentiation, no? Yeah, 4 pi r. Excellent, well spotted, thank God. Okay, so then when you get 4 pi r cube, yeah, once you get that, you know this and this can be cancelled. So r cube is equal to 50 by pi. R therefore is 50 to the power 1 by 3 by pi to the power 1 by 3. You got your r. Take it and go back here. You want to find h. Substitute there. H is equal to 100 by pi r square. H is equal to 100 by pi r square, where r itself is 50 to the power 1 by 3 will become 2 by 3. By pi to the power 1 by 3, pi to the power 2 by 3. You can write 100 as 50 into 2. By pi to the power 1 and pi to the power 2 by 3 will become pi to the power 1 by 3. into 50 to the power 2 by 3. Now 5 to the power 1 and 5 to the power 2 by 3 will become 5 to the power 1 by 3. Correct? By pi to the power 1 by 3 into 2. Hence you see that height is 2 times the radius. What are they asking?
Minimum surface area.
Find the dimensions of the can, which we found. We found the dimensions of R and H when the surface area is minimum. So take the differentiated value and double differentiate it and see if it's minimum or maximum. It will be 200 into plus 2 by R cube plus a 4 pi. It's definitely positive and therefore it is minima. The condition is for minima. Are you clear?
Yes.
So that completes the 20th question, 21st question. Okay, enough for today. Please finish till here.